Okay, this lesson is a review of some basic logic concepts. We're going to talk about conditional statements and inverse, converse, and contrapositive. We're going to talk about inductive versus deductive reasoning. We're going to talk about the law of syllogism and the law of detachment. Okay, a conditional statement is just an if-then statement. So this statement right here, if a dog is wet, then it stinks, that is a conditional statement. Every conditional has two parts to it. It has a hypothesis, which is the part that's usually with the word if. So that's the hypothesis. Then it has a conclusion, which is the then part. Okay? So the hypothesis is a dog is wet. The conclusion is it stinks. And we will rearrange those to form the inverse, converse, and contrapositive. But first things first. If I ask you to write the conditional, in a problem like this, you're just going to recopy the existing sentence. So there it is. If a dog is wet, then it stinks. Now, the hypothesis, we often will model the hypothesis with the letter P, and we will model the conclusion with the letter Q. So if you keep that in mind, a conditional is of the form if P, then Q. Okay, and I'll use these symbols to mean if P, then Q. So with that in mind, the inverse, for the inverse, we just negate the hypothesis and conclusion. And the symbol for that is like this. If I put a tilde in front of it, that means not P. And if I pulled a tilde here, that means not Q. So the order doesn't change. So if the original statement is if a dog is wet, then it stinks, the inverse is going to be if a dog is not wet, then it does not stink. Okay, so the inverse is going to look like this. And the biggest mistake the students will make is they mix up which is which, the inverse and the converse. Because for the converse, you don't negate, but you reverse the order. So the converse works like this. If Q, then P. So since the original statement is if a dog is wet, then it stinks, if I want to form the converse, that's the one where you reverse the hypothesis and conclusion. So this will become if it stinks, then the dog is wet. Notice I have to change a couple words for it to make grammatical sense. That's okay. Okay, make the small changes necessary for grammar. Okay, so if it stinks, then the dog is wet. That would be the converse. Now, so to review, for inverse is the one where we just negate the hypothesis and conclusion. If not P, then not Q. The converse is the one where we reverse the order of the hypothesis and conclusion. If Q, then P. The contrapositive is the one where we do both things at the same time. So we're going to wind up saying, we're going to reverse. So we're going to wind up saying, if not Q, then not P. See, I've reversed the hypothesis and conclusion, and I'm negating them also. So I can sort of get the contrapositive from the converse. The converse, we've already reversed them. So I can sort of use this as a model, okay? If it stinks, then it's a dog. That's already backwards. So all I need to do is go ahead and negate that, and then that should be my contrapositive. So if it does not stink, then the dog is not wet. That would be the contrapositive. Okay, so the contrapositive is sort of like the inverse and converse combined. Okay, so if I had the inverse, which is already negated, I could just reverse it, and then that would be the contrapositive. Okay, let's move on. All right, number 2. The first 4 numbers of a sequence are 4, 8, 16, and 32. You predict that the next number is 64. Did you use inductive or deductive reasoning? Explain. Okay, just in a nutshell, the difference between inductive and deductive reasoning. Here's what you need to know about inductive and deductive reasoning. Inductive is a type of reasoning where you're basing your predictions on a pattern that you've observed, and you're sort of making an educated guess. Deductive reasoning is what you're doing when you're following rules and facts, and you're going from one step to another. When you arrive at a conclusion based on deductive reasoning, it's really not a guess. It's more or less a fact. Okay, so on this problem, we're seeing that we have the numbers 4, 8, 16, and 32. So far, from 4 to 8, it doubled. From 8 to 16, it doubled. From 16 to 32, it doubled. So based on that pattern, we would predict that the next number is going to be 64. So we would predict it would double again. But there's no law that says the next number has to be 64. The next number could be anything. But using inductive reasoning, by observing this pattern, we would probably, if we had a guess, we would predict that the next number is 64. All right, but that is inductive reasoning. On the other hand, if you say, look, 2x plus 3 is equal to 11. And based on that, you decide, well, if that's, say if this is what you're given, if then you decide that, well, guess what, 2x is going to equal 8. And then if that's true, then x is going to equal 4. So from starting with this, you're concluding with this. Now that conclusion, that x is equal to 4, that was deductive reasoning, because every step I made was based on rules, the rules of algebra. From step 1, from the beginning to step 1, we subtracted 3 from both sides. In step 2, we divided both sides by 2. Okay, and those are all rules of algebra that we're allowed to do that, and it should still be an equation. So when you follow rules like that, that's deductive reasoning. Or say there was a problem where Johnny observed that the speed limit is 55. He noticed that his friend Jeff was driving 80 miles an hour. He predicted that his friend Jeff was going to get a ticket. That would be based on deductive reasoning, because the speed limit is 55. If you drive 80, you're going to get a ticket. Alright, so deductive reasoning is based on rules and accepted facts, whereas inductive reasoning is you're sort of making an educated guess based on a pattern that you've observed. Okay, so that was an example of deductive. Alright, anyway, so now moving on to syllogism and detachment. The law of syllogism is sometimes referred to as the chain rule. Because syllogism is the one that works like a chain. It's sort of like this. So here's a model of syllogism. Syllogism goes, if A happens, then B happens. If B happens, then C happens. So, if A happens, then C happens. That's like the conclusion. Okay, so you can see the chain. If A leads to B and B leads to C, then A will lead to C. It's like a chain. So that is syllogism. So we're going to use the law of syllogism to write a conclusion. So understand the conclusion of syllogism is this new if-then statement that connects the first thing and the last thing. So that will, our conclusion will be an if A then C situation. All right, let's see what we've got. If you win the baseball game, okay, so that's sort of like A, then your coach will be happy. All right, then your coach will be happy. So that's sort of like B. If your coach is happy, all right, there's your B again, then you will not have to run laps at the next practice. That's like our C. Okay? So, if A then B, if B then C, the conclusion is if A then C. So our conclusion is going to be if you win the baseball game, then you will not have to run laps at the next practice. If A then C, the beginning and the end of the chain, that's how you do the law of syllogism. So again, this is what the answer would be like. This would be the conclusion of syllogism. Notice the conclusion of a syllogism, using syllogism, is a conditional. It's an if-then statement. If you win the baseball game, then you will not have to run laps at the next practice. I'm emphasizing that because the law of detachment does not give you an if-then statement. It's just a conclusion, not a hypothesis and a conclusion like syllogism. Let's take a look. Here's how the law of detachment works. All right, detachment is kind of silly to me because it comes down to common sense. It really comes down to common sense. If you have an if-then statement, it's always like this. If A happens, then B happens. Okay? But in detachment, we're given one more piece of information. Guess what? A happens. Well, what can we conclude then? Well, we just said it 2 seconds ago. If we said that if A happens, then B happens. So if then you tell me that A happens, my conclusion is going to be B happens. Okay, that is my conclusion. B happens. So, the conclusion using detachment is going to be just a single statement of the form B happens. Okay, compare that with the conclusion of syllogism. Remember, for syllogism, we had this the conclusion was of the form if A happens, then C happens. All right, it was a whole if-then statement for syllogism. But detachment, the conclusion is just B happens. All right, so let's see how that looks in an example. All right, If someone answers a question correctly, the whole class will clap. Jake answered a homework question correctly. What can you conclude? Hopefully you thought the whole class will clap. We just said if someone answers a question correctly, the whole class will clap. Well, guess what? Someone answered a question correctly. So guess what? The whole class will clap. So the biggest mistake that I see students make is when they go to write their conclusion, they will write a whole if-then statement. They'll say something like, since someone answered a question correctly, then the whole class clapped. You don't do that for detachment. For detachment, you just say that final statement, the be happens part. So you will just go like this. The whole class clapped. That's it. Be happens. Okay, that's how detachment works. Alright, these last few problems are more examples of inverse, converse, and contrapositive. So let's review that. Here's a little pop quiz. Alright, the choices are inverse, converse, and contrapositive. Which one is the one where we reverse the order of the statements and kind of say it backwards? We reverse the hypothesis and conclusion. Is that inverse, converse, or contrapositive? That is the converse. The converse is the one where you reverse the order. Which is the one where we don't reverse the order, but we just negate everything. Not this, not that. That's the inverse. The inverse is the one where we just negate. The converse is the one where we reverse them. And of course the contrapositive. How do we make the contrapositive? We do both things. For the contrapositive, we reverse the order and we negate. Okay? So remember, in symbols, if the original statement is if P then Q, then the inverse is if not P then not Q, and the converse is if Q then P, and the contrapositive is if not Q then not P. So that's what we're twerking with. Alright, so number 5. What is the converse of this statement? Let's remember that the converse is if Q then P. It's the one where we reverse them. So if you are hungry, then you did not eat breakfast. So you are hungry is the hypothesis. You did not eat breakfast is the conclusion. So the converse will be what we get if we reverse these. So it should be something like if you did not eat breakfast, then you are hungry. Something like that. Oh look, it's A. Boom. Kabam. Alright, let's look at number 6. Now we're, okay, that was the converse. So in number 6, we're talking inverse. Remember, the inverse is the one where we just negate. So if not P, then not Q. We just negate. If water is ice, then the water's temperature is 32 degrees. So it should be something like if water is not ice, then the water's temperature is not 32 degrees. But we don't reverse anything. We just put a not in there. Okay, we just negate. So let's see. If water is not ice, that's kind of what I'm looking for. B has it, if water is not ice. Okay, B is looking good so far. If water is not ice, then its temperature is not 32 degrees. Kabam, there it is. We just negated. We did not switch. Reverse, reverse. Alright, now the contrapositive. This is the one where we reverse and negate. Okay, so we're doing the contrapositive. So this is going to be if not Q, then not P. Okay, so if it does not rain, okay, that's my P. Then we will be in a drought. That's my Q. So we have to reverse these and negate them. So if we reverse these, it will be we will be in a drought will come first, and it does not rain will come second. Alright, so focus on the we will be in a drought part. That will be over here. But since we're going to negate it, it's going to be like we will not be in a drought. Okay, now this one over here says it does not rain. If we reverse it, the part about raining will be over here, but we're going to negate it. So this says it does not rain. If we negate that, it will be like it does rain. Alright, if it already has a not in it, if you negate it, you make it true. So we're looking for something that says something about if you're not in a drought, then it rains, or something like that. So let's see, if we're not in a drought, then it does not rain. That's close, but we need to negate this not raining thing and make it a positive statement that it does rain. So it's not A. Okay, let's see. So here we go again. We're looking for not drought. If we are in a drought, see, that's already wrong. We need not drought. So it's not B. If we are not in a drought, so far so good, then it rains. Kabam! There it is. It is C. Okay, so that was just some more practice on inverse, converse, and contrapositive. Alright, that's the end of this mini review of logic.